Hello everyone, welcome back to my channel. So in this video, we are going to graph the y equals absolute value of 2x plus 3 by using the piecewise function format. So the reason why I'm using the piecewise function format to help you understand the graph because I want you guys to practice lots of piecewise function, how we can rewrite absolute value function to its piecewise function. So this is the best practice for all of you. So how could we actually write y equals absolute value of 2x plus 3 to a piecewise function? So you see, right, this is a more complex structure here. So basically, it's really easy topics. It's really easy. So basically, you see that I'm going to replace every x here by 2x plus 3. So this is the goal of rewriting the piecewise function, right? Okay, so if I replace every x here by 2x plus 3, I should get something like this. So y equals 2x plus 3 if 2x plus 3 is greater or equal to 0. Y equals negative 2x plus 3 when 2x plus 3 is less than 0. So this is the first step I'm going to do. So notice that this one 2x plus 3 greater or equal to 0 doesn't match with the upper one, the previous one. So we will see that the x and the numbers are isolated. So the x must be in one side and all the numbers must be in the other side. So which means that I need to solve these two inequalities for the next step. So the second step involving solving for these inequalities 2x plus 3 greater or equal to 0, 2x plus 3 less than 0. So how could we actually solve that? So remember for previous video, I can treat these inequalities by equations. I can rewrite this expression as 2x plus 3 equals 0. And I'm going to isolate all the numbers to the other side. So the first thing we are going to do is to isolate plus 3 to the other side. So it becomes 2x equals to negative 3. And I'm going to move the 2 to the other side as well by dividing by 2. So we have x equals to negative 3 over 2. So basically, I'm not going to change the sign here and keeping the sign as x greater or equals to negative 3 over 2, x less than negative 3 over 2. So this is the purpose, and this is the second step. So basically, this is your final answers when you're going to solve for these inequalities. So I place it here, and I also simplify this bracket out and just do it at negative 2x minus 3. And this one is my final answer. So at this stage, we have already figured out the piecewise function for y equals absolute value function of 2x plus 3. And this one and this one is equal to the same. And graphing of y equals absolute value of a function of 2x plus 3 is the same thing graphing of this thing here, the whole thing here. So remember how we can interpret this piecewise function here? Right, so y equals 2x plus 3 when x is greater or equals to negative 3 over 2, right? So y equals to negative 2x minus 3 when x is less than negative 3 over 2. So basically, we have two portions of function, but we have different domain, right? So the first thing I want to graph is the first piece here, 2x plus 3, when x is greater or equals to negative 3 over 2. So I should start at this value here, negative 3 over 2. I'm going to plug in this value, 3 over 2, to this expression here, 2x plus 3. So basically, if we plug in negative 3 over 2 to this expression here, we get the y value equals to 0. So basically, this is where I'm going to start here. And I'm going to draw the line with positive slope equals to 2 because I know that 2x plus 3 has a positive slope equals to 2. So don't forget we also have the second piece function here, y equals to negative 2x minus 3 when x is less than negative 3 over 2. So same thing for this one, we're going to plug in x equals to negative 3 over 2 to this expression here, negative 2x minus 3. And it gives me y value equals to 0, right? So for x less than negative 3 over 2, we have a negative slope. So for every x value less than negative 3 over 2, we have a negative slope. And this one would be my final graph for absolute value of 2x plus 3.